Hello, everybody. Today we're going to be learning about quadratics. What is a quadratic, you may ask? So, when we see an expression, an algebraic expression, like y equals ax plus b, this is known as a linear expression because the degree of the variable is 1. But when we have a polynomial with the degree of the variable as 2, like 3x squared, for example. The degree of the variable is 2. So this is known as a quadratic. What is a degree, you may ask? A degree is the highest power of the variable in a given expression. So here, as you can see, there's no other terms in this expression. So the degree of the variable is 2. Now, what is the general form of a quadratic? A quadratic is generally in this form: y equals ax squared plus bx plus c. This is the general form of a quadratic expression because let's say if you have like a quadratic 3x squared minus 5x plus 6. You can see here that a equals 3, b equals -5, and c equals 6. So we're going to be learning more about quadratics, how their graph functions, roots of quadratic equations, and relations between the roots and the coefficients. First, we're going to learn what a quadratic equation is. So a quadratic expression is when we set y equals ax squared plus bx plus c. So this is like a quadratic expression because we have some variable y, and if we set y equals 0, then we get a quadratic equation: ax squared plus bx plus c equals 0. Now, if we solve for x in this expression, like, we could consider that a, b, and c belong to real numbers because let's say like they were non-real coefficients, then you would get non-real roots. But as the roots belong to real real numbers, the coefficients will also belong to real numbers. There are some cases where the coefficients are real, but there are no roots of the equation. And we're going to talk about that later. And for a quadratic equation, a should not be equal to 0. Because if a is 0, then we would be left with bx plus c equals 0. And since if bx plus c equals 0, then you can see the degree of the whole expression is 1 and not 2. So a is not equal to 0. But let's just say that a was equal to 0. Let's say a is equal to 0. Then we get a linear equation. And that would be bx plus c equals 0. Which would give us one root, which is minus c over b. Now let's say ax squared plus bx plus c equals 0. And a and b are equal to 0. Then we would get a contradiction for where c is not equal to 0. Let's say c isn't equal to 0. Then we would get 0x squared plus 0x plus c equals 0. And as you can see, this becomes 0. But if c is not equal to 0, but as per the equation c equals 0, you can see this is a contradiction, which means in this case we would get a contradiction. Now let's assume that ax squared plus bx plus c equals 0. And how many roots would a quadratic have? Now, anything with a degree 2 has at maximum 2 roots. So let's say an equation with the degree 2 has at maximum 2 roots. Now, what is a root? A root is a solution for this equation right here. Now, let's say we have ax plus b equals 0. A root is the value of x for which this equals 0. Now, if we solve for this value here, we get ax equals negative b, and x equals negative b over a. So the root of this equation is negative b over a. And as you can see, we only got one root. And the reason we only got one root is because the degree of this polynomial is 1 and not 2. But if the degree is 2, you get 2 roots. And if the degree is 3, you get 3 roots, and so on. So let's say we try solving for the roots of this polynomial. Ax squared plus bx plus c equals 0. Now, let's divide both sides by a. Now, this would be, now, we know that 0 over anything is still 0. So, and we know that we also know that a is not equal to 0. So this would not be an indeterminate form, and it would cancel out just to give 0. So on the left-hand side, we can cancel these out, or like distribute all of these under these three terms. So even if you cancel these out, you still have to distribute them under the other terms. And now, if we subtract negative c, if we subtract c over a from both sides, and this is a method used for solving quadratics called completing the square, which I will make a tutorial on for now. And this part isn't really important for your preparation for an exam or anything. This is just a derivation of a quadratic formula. But if you know completing the square, then you can follow along. We're going to add b by 2a whole square on both sides. And now, we're going to expand this. So this left-hand side, all of this combined is actually x plus b over 2a whole squared. And on the right-hand side, by simplifying this fraction, we get b squared minus 4ac over 4a squared. Now, if we take the square root of both sides, then we would get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. And let's subtract minus b over 2a from both sides. Or, my bad. B over 2a from both sides. And as you can see, the denominator is the same. So we're just going to join the terms on the numerator. And this is your quadratic formula. So from this, we can actually determine the relationship between roots and coefficients. And let's say you have a quadratic. You can solve it using this formula right here. By comparing it with like the general form of a quadratic. Let's say you have x squared minus 5x plus 6 equals 0. Now, by comparing it with a general form of a quadratic, you can see here that A equals 1, B equals -5, and C equals 6. So let's plug it into the formula. You know x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now, we know that b is -5. So negative b equals negative of -5, which is +5. So 5 plus or minus the square root of b squared minus 4ac. B squared minus 4ac is -5 squared minus 4 times 1 times 6. And negative times negative is positive. So this is 25 minus 24 equals 1. And the square root of 1 is 1. And we know the 2a. How do we get 2a? We know that a equals 1. So 2 times 1 equals 2. And we know that square root of 1 is just 1. So we'll get 5 plus or minus 1 over 2. Now from this, one time we'll take 5 minus 1 over 2, and another time we'll take 5 plus 1 over 2. And from 5 minus 1 over 2, we get 4 over 2, which is just 2. And from 5 plus 1 over 2, we get 6 over 2, which is 3. So we found the roots of x squared minus 5x plus 6 equals 0. The roots are 2 and 3, which means if you substitute 2 or 3 inside this equation, you'll get 0. Let's test it out. 2 squared minus 5 times 2 plus 6 equals 0. 4 minus 10 plus 6 equals 0. 4 minus 10 is -6 plus 6, which is 0. And let's test it with 3. 3 squared minus 5 times 3 plus 6 equals 0. 9 minus 15 plus 6. -15 plus 6 is -9. -9 plus 9 equals 0. So as you can see, these roots are like numbers which satisfy this equation. So in the general form of a quadratic, ax squared plus bx plus c, you're going to have two roots, alpha and beta. So these two roots, we can solve for them using the quadratic formula. And we have two formulas actually. Alpha plus beta equals -b over a, and alpha times beta equals c over a. Now, how did these formulas even come? Now, alpha plus beta equals -b over a. We know that x equals -b plus or minus the square root of b squared minus 4ac over 2a. So we know that these are two different roots. One is -b plus the square root of b squared minus 4ac over 2a, and the other one being -b minus the square root of b squared minus 4ac over 2a. So we'll let one of these equal alpha, let's say plus. It doesn't matter which one you choose. And the other one, beta, let's say it equals -b minus the square root of b squared minus 4ac over 2a. Now, we need to prove that alpha plus beta equals -b over a. How do we do this? We can say that -b plus the square root of b squared minus 4ac over 2a plus -b minus the square root of b squared minus 4ac equals -b over a. Now we can prove this. The denominators are the same, so we can just join these two terms. And we'll just erase this. And we can see that these two cancel out, and this becomes minus 2b over 2a. The 2's cancel out, which give us minus b over a. Now the same goes with for multiplication. Alpha times beta minus b plus the square root of b squared minus 4ac times minus b minus the square root of b squared minus 4ac over 2a times 2a, which is 4a squared. So when we multiply this, we can see this is a classic difference of squares, where a plus b times a minus b equals a squared minus b squared. So this would be minus b squared minus the square root of b squared minus 4ac squared. And this gives us b squared minus b squared minus 4ac over 4a squared. And this would, so this multiplication sign, negative sign, we can multiply it. This becomes plus, and if we just rewrite this, this would be minus b squared plus 4ac. These cancel out, and this gives us 4ac over 4a squared. These 4's cancel out, and 1a cancels out, giving us c over a. So these two formulas are very important for us right now. Alpha plus beta equals negative b over a, and alpha times beta equals c over a. Now, let's try some problems with these formulas. So let's say I give you a a quadratic equation, x squared plus 2x plus 1 equals 0. What is the sum of roots? And what is the product of roots? You're free to pause the video and solve it for yourself. So alpha plus beta equals minus b over a, which is negative 2. And product of roots is alpha times beta, which is c over a, which is 1. Sum of roots equals negative b over a. Alright, so next one. What if I give you x squared minus 5x plus 6 equals 0? Now, alpha plus beta equals negative b over a, which is equal to negative 5 over 1, which is 5. And alpha times beta equals c over a, which is 6 over 1, which is 6. So you can see these really come in handy when you're asked about relations between roots and coefficients. And you can save time by not having to solve the equation and adding them manually. So our next topic is going to be the discriminants. Now, what is a discriminant, you may ask? A discriminant is just b squared minus 4ac. And basically, you can see in the quadratic formula, you get minus b plus or minus the square root of b squared minus 4ac over 2a. And there's actually some rules. If the discriminant is greater than 0, you're going to get two real and distinct roots. And if the discriminant is equal to 0, you're going to get two real and equal roots. And if the discriminant is going to be less than 0, you get two imaginary and distinct roots. Now, how does this work? Like, let's say if this quantity is greater than 0, right? Now, this would be a radical expression, or it would simplify to some perfect squared, in which you get two roots, minus b plus the square root of d over 2a, and minus b minus the square root of d over 2a. Let's just do this on a new page. So, we're going to get two real roots. Now, let's say this discriminant is equal to 0. Then we get minus b by 2a plus or minus the square root of 0, which is just 0. And plus or minus 0, it really doesn't matter. We're adding 0, which means our answer is going to be minus b over 2a. And I know it's a quadratic, but we still get one root. Because in the beginning of the video, I told you that a quadratic has maximum 2 roots, not minimum. Minimum, it can have 0 roots, and that's what I'm going to get into now. Let's say you get minus b plus or minus the square root of d over 2a, where d is less than 0. Now, if the discriminant is less than 0, you're going to get a negative number inside of the square root, which does not work because let's say x squared plus 1 equals 0. You solve for x, you get x squared equals negative 1, and x equals the square root of negative 1. What is the square root of negative 1? There is no square root of negative 1 because negative 1 times negative 1 equals positive 1, and positive 1 times positive 1 is also equal to positive 1. And in the same way, you can't take the square root of any negative number. So you're going to get an imaginary quantity, which I'm going to discuss in depth in the next video. So these are the rules for the discriminant. If you have real roots, so not real and distinct, but if you have real roots, the rule is the discriminant is greater than or equal to 0. And this splits into two cases, as I showed you. The discriminant is greater than 0, where the roots are distinct, which means they're conjugates of each other. What is a conjugate? A conjugate is basically where one is like positive and one is negative. So not exactly the real definition, but let's say you get let's just take an example. Minus 2 plus or minus the square root of 3 over 2. Let's say that. Let's say this is our root. So one of it would be minus 2 minus the square root of 3 over 2. And the other one would be minus 2 plus the square root of 3 over 2. And as you can see, they are conjugates of each other. One is plus and one is minus. So that's what happens when the discriminant is greater than 0 and also when it is less than 0. So you remember when we said x equals the square root of negative 1, where x squared plus 1 equals 0, right? The square root of negative 1 has a special name called I, or more often known iota. So this is used to determine like square root of negative numbers. Let's say the square root of negative 4 would be the square root of negative 1 times the square root of 4. And we know this is I, and this is 2. So we get 2I. So we would still get conjugate pairs. Like let's say if I say what's a quadratic that has no roots? X squared plus x plus 1 equals 0. Now, if you try to solve for the roots of this equation, you're going to get, like, imaginary quantities, like minus b, which is negative 1, plus or minus the square root of b squared, which is 1, minus 4ac, 1 minus 4, over 2a. So this is minus 1 plus or minus the square root of negative 3 over 2. And as you know, there is no square root of negative 3. So this would be minus 1 plus or minus the square root of 3i over 2. So as you can see, they still come in conjugate pairs. One is minus 1 plus the square root of 3i over 2. And the other one is minus 1 minus the square root of 3i over 2. So they still come in conjugate pairs no matter what. But let's say, so the reason they come in conjugate pairs is when we take the general form of a quadratic, the coefficients are real. But as soon as the coefficients are not real and they start taking complex number forms, they don't come in conjugate pairs. Or there is one case where if they are real, but they still don't have conjugate pairs, is when the discriminant is equal to 0. Because we would just get minus b over 2a, which is one root. Now, a quadratic can be graphed, and the shape of a quadratic graph is a parabola. A parabola is basically, it's like a U shape, something like this. So as you can see, when it doesn't, let me draw it a little bit better. So, when it touches the x-axis at one point, you can see this is one root. One root means where y equals 0, right? So when we set this quadratic expression equal to 0, we set y equals 0, right? And we get ax squared plus bx plus c equals 0. And when we get this equals 0, that means we're directly keeping, like, subbing y as 0. So when the quadratic graph or the parabola touches the x-axis at one point, you have exactly one root. And let's say it touches the graph something like this at 2 points exactly. That means your discriminant here is greater than 0, which means what? You have two roots, or 2 points where y equals 0. 2 points where y equals 0. And if your discriminant is less than 0, it will not intersect with the x-axis. And the reason for this being, there is no value of x for which y equals 0. And that's when your discriminant is negative or less than 0, for which the graph will not touch the x-axis. So that was an introduction to quadratic equations and expressions from Algebra 2. If you liked the video and if you have any tips to improve my teaching style, then please comment down below. And be on lookout for the next video where I will be teaching quadratic equations again, but a more in-depth version. Like this is like this would be a introduction to quadratics, and the next one would be the full in detail course on quadratics, and then I'll be starting complex identities and numbers. So stay tuned, like, subscribe, and have a good day.